Hey guys, welcome back to the BVM F-16 1/5 scale Venom Scheme build series. We are doing video number 3. We've got lots of cool things obviously planned for this aircraft. If you've missed the previous videos, I suggest you watch them. There's some things that have gone over from the first video to the second video to this video, so definitely check those out if you've missed them. But let's dive back in to this aircraft. All right, so we're going to move on to the tanks here. What we're going to do is we're going to pull the bungs out of each tank, inspect them. We're going to pull the fuel tubing that we cut off of these fittings, and ultimately we want to check and make sure that these tanks are leak-free. Now it looks like there's some sort of liquid that they put in here. I hope it's not water, so we will also check that out as well. It doesn't smell like anything, so I don't know. I sure hope they didn't use water in this fuel system. We're going to rinse these tanks out with isopropyl alcohol or rubbing alcohol, 99%. That'll take care of any moisture inside these tanks as well. Okay, so we've pulled the bungs out of both tanks here. The first thing that we're checking for is to make sure our tubing length here is the same, which it is. They've made both of these the same. So I've also put these inside the tanks, rotate it in all directions. The clunks don't get hung up, and they seem to work really well with this fuel system. The other benefit of this fuel system, this is the bottom of the tank here. So you've got this nice angle and then the little channel down here feeding all the fuel into this area. So it's actually a really good tank design for such a weird shape. So that's a positive. So what we'll do is we're going to tie wire these 4 points, and we're going to rinse out the tanks with rubbing alcohol. Then we're going to reassemble the tanks with the bung fitting, and we're going to check and make sure that there is no leaks by pressurizing them. So this is pretty typical BVM stuff. So what I'll do in this case is I'm going to take a little bit of silicone oil and just put it on both sides of our rubber O-ring piece. And that ensures that everything seals really nicely. So we'll do that side, spin it around, and then we'll do this side and spin it around. And I was just inspecting the bung fitting in the tank, and there was a little bit of glue residue built up around the fitting. So I just took my plane and we just very carefully cleaned up the glue residue around the fitting, because that glue residue could prevent the O-ring from sealing properly. Pressurizing tanks, we put a little piece of Tygon over top of the vent line. We put our bung and clunk fitting and everything that's been tie wired back into the tank. Tank's been cleaned out with rubbing alcohol, 99% rubbing alcohol. So what we'll do now is pressurize the system with our mouths through the main fitting and line here, and then we'll just clamp it off with a pair of forceps, or whatever you call these things. So you basically don't want to use compressed air. The air from your mouth is plenty. I just put in as much pressure as I can get with my mouth, and now we're good. So what I'll generally do is just spray around the fittings and just to double check that everything's working good and sealing properly. And if that is sealed, then we'll just leave this sit for a while and confirm that it is good. Now you can leave this sit for 4 hours or overnight is awesome, but basically at some period of time that's reasonably long to allow the air to escape if there is a hole. Now alternatively, you can dunk the fuel tanks underwater. That's totally fine as well too. I just prefer this method because it's simple, easy, and we've always got other things to do while the pressurized tank sits doing its thing. All right, so I'm just pulling out the smoke tank system here and just kind of going through all the different systems and everything. And we've got a pretty awesome setup right there for the feeding the smoke pump. That's not how you do it, in case you're wondering. Okay, so we pulled out the smoke tanks, one on each side. And the point of this pulling out the smoke tanks is, if you look back in that far corner, it's going to be hard to see, but there is one of the bolts in those far edges back there. and those are the guys that hold the fuselage together right there. So they're right here on the edges of the fuselage where the seam is. So we need to get the smoke tanks out anyways to assess those things. So what we'll do when the tanks are all out is we're going to get into the nuts and bolts, literally, of everything holding this aircraft together. So we've got all of our bolts that hold the fuselage pieces together that we need to address, and then the fasteners that hold the intake portion with the nose portion, and those can be seen right in this area, kind of around the loop around the whole front part of this aircraft. So those are all the things that we want to address. Right now I'm just pulling out this tank mount here. This is for the front tank, we'll call it, in the fuel system, and just pulling this out to get good access to underneath this area. So none of this stuff is Loctited as well, so I mean this isn't super critical, but obviously this is going to come loose if you don't add Loctite to this item. So now with that out, we've got good access here to all of our systems, our cylinders here that run the doors. We can add oil to each side of the cylinder, so that's the reasoning to open up all the stuff in this aircraft. And then our bolt, one of the bolts holding the fuselage together, is right there. Okay, so we did pull the forceps, the little clamp things, off of the tanks, and all of the tanks held air. So that is a huge positive thing there. I was worried about that. Now all of our lines are going to get changed. We're not reusing any of this line, so we're going to be going with 8mm Festo line, which is kind of the norm. I mean, when you're dealing with an engine this size, you really want to make sure you're at a high flow fuel situation. So that's all going to get changed as well. Well, we have success. Our molds successfully pulled from the plugs, and everything looks like it worked out good. We have a very thick amount of fiberglass and resin on the back side. Now there is a couple little touch-ups here and there, but nothing too major. So we're going to take this to the belt sander, get all the fiberglass sanded off the perimeter, and then we're going to do our little touch-ups here before we think about using these molds. So very happy that that worked out. All right, so next thing we want to do on the fuselage is go over all of our fasteners. So, because I suspect they may not be done. All right, so we've got all of our fuselage fasteners Loctited and tightened. Now what we're going to do is we're going to flip the aircraft upside down, and we are going to get the gear all done. So what I'm going to do is get all the main gear stuff that I can access from the gear being down, and then a bunch of this stuff we'll have to do from this position, but I'll do as much as I can on the actual gear first, and then we will do all the fasteners holding the structure in place. So this is also another important step with any manufactured aircraft. Generally none of their gear stuff comes Loctited. So we're going to make sure we do the mains and of course the front, which we haven't really looked at all yet. All right, so we've got the aircraft upside down, good access for all this stuff, and it's a lot easier to get this aircraft upside down when it's not full of all of its components and engine and everything. So good view of the gear. I think we'll be able to access everything from the underside, so this is good. And first thing I'm doing here is starting with the wheels, and I'll work my way inwards. Now the wheels are fairly easy to take off. The manual covers this. There's 2 Allen keys right here, and the wheel simply comes out. Quite a bit of dust on here. Looks like they've already pre-lubed the O-rings, which is nice. And we've got a bunch of crap inside the wheel there. So we'll just clean all this up. And these wheels don't have bearings, they've got bushings. Make sure you don't lose your little plastic bushing there. So that is the setup. So we're going to go around and Loctite all these guys as well. And these tires are not solid, but there's no air adjustment on the tires, so they are what they are, which is fine. All right, guys, and it is time for another episode of Tip Time, and this Tip Time is brought to you by Trusty Bent Screwdriver. Okay, so this tip time doesn't revolve around Loctite. I know we've talked about Loctite a ton. What this actually revolves around is doing jobs like Loctite or with Loctite. So when I'm doing a gear Loctite session, or in this case, a wheel Loctite session, I'll make sure that I don't stop in between. I mean, if the house is burning down or you know, something crazy is going on, obviously that doesn't matter anymore. But if my lovely wife was to come into the shop as an example, I'm not just going to stop what I'm doing and help her. I'm going to say, okay, I just need 2 more minutes to finish doing what I've started here, and then I'll come help you. Because when you get interrupted like that, that's when you're going to miss things. So the other thing I'll do is pick a starting point here. So we've got 1 label on this tire. Try and get the camera there. So we've got the label 5.5 inches, the size, and that's my starting point. So I've done 2 of these screws already. I'm just going to keep going around the circle until we've got everything Loctited. So I do also use a paint marker and just put a little paint mark on the tire, which is easy to remove afterwards. So little tip time for you about how not to screw up doing Loctite. So thanks guys, and let's get this done. All right, so we've got our wheel back installed, we've got our brakes relubed, and to get the axle set down all the way, there's a little plastic cover over the end of the axle. So you need to take the plastic cover off to be able to push the axle all the way down. Otherwise, it's not going to seat properly because there's a bit of space in this area. So I've temporarily done up the fixing bolts there just to check our end bolt and make sure that there's Loctite on there, which there was Loctite on there, so that is good. So we'll tighten this guy back down, put our plastic cap on after we get these guys seated down properly. All right, so I want to get rid of the zip tie holders here on the brake line, so I'm just printing off some little carbon fiber holders that we're going to glue onto the leg here, and that's going to be a nice cleaner look than having the zip ties. Super simple, designed it in Tinkercad, took 3 iterations to get the right dimensions and stuff, so now I'm just printing 13 of them. I only need 8. And it's going to take about 8 minutes to print them. All right, so 9 minutes later, the brake airline holders came out perfect. Printed these with PETG carbon fiber. Come on, camera focus. So really hard to show you what the actual shape looks like, but that is basically what it looks like. So it's a circle, another circle inside, 2.5 millimeter inside circle because the line is 2 millimeters, and a little flat spot built on there. So super simple, nice and quick to pound those off, and we'll install these guys on the legs. So what we'll do is we'll just replace the zip ties with those little keepers, but we'll take our Dremel and just do a little zip sand there where we're going to put those keepers, and they should work good. All right, so getting ready to install our little keepers. What I did was I just marked out, or kind of made a mental note here of where our marks are, or our existing zip ties, and this guy up here right on the little linkage, come on, focus, right there, and took my Dremel and just basically sanded down the paint. So when we use CA to clip these things on or glue them on, they've actually got something to grab to. That's important. So let's take a quick look at this again. Stock layout with zip ties and 3D keeper layout. That looks so much better. So much better. So this line right now is just kind of floating in there. If you want to make it a little more solid, you could use shoe goop on there. You could put a little drop of CA as well. We'll cycle the gear and just see how it works, but I don't think there's any issue just leaving it loose. Other than maybe that spot right there, it'll bunch up. So what I'll probably end up doing is just taking a little bit of CA and just putting a drop in each hole so the line is nice and stuck. All right, so we've gone through the main landing gear. That is complete. All of our fasteners that we could see from the underside are done. The only fasteners we have left to do is the ones on this back plate, but everything else on the center line and all that stuff is done. We've lubed all of our pivot points with dry lube, and the main gear is good. So when we flip the aircraft back over, that's when we'll do the stuff on the other side of the plate. Even the lock nuts there, made sure we tighten those guys up because they were loose. The main gear, now there's 4 holding bolts which are in each corner of the main gear, so 2 here, 2 there. We've undone those, and that's allowed us access to the landing gear here. So fairly straightforward. We're going to do our side bolts, all of these guys on this side, same ones on the other side, and we're going to lube all the pivots and all the standard stuff, and then we'll do the wheel last because you got easy access to the wheel on the front. So we'll get the front done and get that back installed. So just some suggestions here when you're dealing with stuff like the landing gear. You want to make sure you look everywhere. So when we flip this gear over, we've got some bolts hidden here. So I did those, of course. You always want to check things like your servo screw servo arm screw. So that had no Loctite on it. We've got nylon lock nuts here. Those have all been checked. And then one other consideration here is our mounts. So we've got aluminum mounts with Allen keys going through, and that is the exact same thing on the back side. So we want to make sure we check those mounts as well. That's kind of an important thing. So when you look at this as well, when this gear door moves, those air lines are rubbing on the fiberglass intake, which is very abrasive and rough. So what we'll do there is we're going to take a piece of Gorilla Tape, slip that underneath, so when this opens and closes, it's now rubbing on smooth Gorilla Tape versus the aggressive fiberglass. So these are all those little things that I try and look at when I'm putting a project like this together. The reason for this is when I build an aircraft, I really want it to be as maintenance-free as possible for a very extended period of time. I mean, if this aircraft gets 300, 600, 1,000 flights on it, that's super successful in my books. And doing these little details, I mean, those little things are not going to affect it on the first 5 or 10 flights, but when it's going to make a difference is when you're 100 flights in, 150, 200 flights in. Those little wear points add up over time. So these are the kind of things to think about while you're doing a project like this. Okay, so we've taken the cylinder off. That gives us better access to putting the tape piece underneath here. Also actually gives us access to this bolt right there. These bolts had no Loctite on there, and they're actually very loose, so it's very imperative you get, I mean, all of these ones service, but those ones as well too. So we're going to get rid of our bolts first. Then we're going to put our tape down. We're going to also deal with this tape around the wires. So there was just like a big piece of tape holding this down. I already took it off. But what we're going to do is just simply CA this to the hinge, and that's going to keep it nice and positioned instead of having just a piece of black tape around there. So we've got everything put back together here. You can see how simple a fix this is. So every time that door closes, there is a huge movement of both of those lines at the base. So without that piece of tape, it's a big problem in the weighting. So nice little fix there. So we've got everything essentially done here. The only thing that we're gonna do coming up is gonna do door locks. Now, 100% we're doing door locks on the mains. Not sure if we're going to do it on the nose yet. We're going to have to see how everything works and strength and everything. What I'd do to check the front is just with the gear in the up position, see if we can, you know, pull the door open, how much force it would take, how that gear is going to hold up versus dropping down. I mean, the mains are the bigger concern because if you look at the mains here, there's no locks or anything, right? They're just floating in place, and it's relying on the air pressure to hold those gear up. A little bit of a different story with the front because there's so much movement here and so much twisting and everything. But we'll see. If we need to add a lock to the front, we're going to do that as well too. We're just going to use some high quality micro servos. So I'm going to get this back installed where it belongs. All right, so our front gear's all done now. Main gear's all done. We've labeled this here fuel and smoke, just so we know. It's pretty obvious when you look through the vents themselves. So the fuel vent is substantially larger than the smoke vent, but obviously seeing those, looking underneath the plane, remembering that the back one's the fuel one is a bit of a pain, so easier just to mark them. All right, so it is time to move back to our tail molds. Now our molds are all prepped and ready to go. We did some filling on them, and the other thing I did, because we use the carbon PLA as our plug, there was a little bit of texture on these molds. So what I ended up doing was just sanding all the gel coat. These dimensions or shapes are obviously quite simple because it's just a square or whatever. But obviously if you had a very complicated shape, that would be different. But we were able to sand out the texture on this. So it's actually quite smooth now. And the gel coat sands out fairly easy. And we're ready to go. So we're going to get all of our cloth pre-cut here. Essentially we're going to be using I think big, fairly large shapes for this. It should bend quite nicely around all the shapes and around the mold, so I'm not too worried about that because this stuff's, it's nice cloth. So anyways, we're going to get some West Systems mixed up and we're going to get our cloth cut out and we are going to make our chute mechanism. Okay, so first thing we've done here is we waxed our molds. That is the first step. I gotta make sure I get rid of the chunky wax in the corners. But yeah, just waxed our molds as a first step using the release wax. And that's good to go. What we'll do now is we're going to mix up some West Systems epoxy using our weight method. So I will mix it up in a clear cup here, and we'll just make sure obviously we mix enough to accomplish this. So basically you're mixing your resin by weight to your hardener. So with the West Systems, the ratio is 5 to 1. So if you do 20 grams of resin, you're doing 4 grams of hardener. So just keep that in mind. So I'm going to get this mixed up and we will show the steps of installing this. All right, so we have our West Systems mixed up. I'm just going to transfer this into a larger cup so we don't have to worry about it so much overflowing. Okay, so I figured out my different cloth sizes here, and the purpose of these different cloth sizes essentially is these ones near the bottom here are wide enough to span the entire width of our piece. So what I'm going to do is I'm going to lay these guys in first. We'll do one on each mold. Actually, we'll just do one mold at a time, and we will get this guy wet. Now this is I guess it's called a wet layup, so we won't be doing any vacuum bagging or anything like that, and it's going to produce a very nice part. So what I'm doing is just working through this. I guess just making sure we've got different overlaps on different sides. And obviously our excess we're just going to cut off. So we still have a bunch of our mixed epoxy left, just to give you some reference there. So that is our layup. It actually looks really good. I'm happy with it. It's actually quite dry. I believe this is 4-ounce fiberglass cloth. So I did one of our big pieces this way, then I did 2 strips this way, and then I did 2 reinforcers this way, overlapping in the middle. Then I did another loop like this, then I did another final one like that. So the reason for the final one is because we're going to cut that end piece off to become our door. So we've got on that end piece, we've got 1, 2, 3, 4, 5, yeah, like 5, 6 layers in this end piece area. So should be plenty strong when it's all cured. So we're going to leave this obviously till tomorrow. The last thing I did here when I was going over this was just make sure our corners were pushed in everywhere. That was an important part because we want those corners to be obviously nicely, nicely shaped basically. So that's that. We're gonna let that set up till tomorrow, and hopefully those should pull out beautifully. So I'm trying to accomplish things that are beneficial while the airplane is upside down. So I want to redo these lights. Not happy with those at all. So we're going to work on that next. A lot of people on the unboxing video gave this kit flack because it's got a tail hook. So let's just set the record straight. I don't know a ton about aircraft, like F-16s, F-35s, all that kind of stuff. So I Googled it. Do F-16s have a tail hook? And basically, a lot of the fighters, jets, aircraft like the F-16, the F-35, a bunch of aircraft that don't normally demonstrate a tail hook have a tail hook. It's for an emergency situation. So F-16s, apparently they have tail hooks. It's very common. If the landing gear fails or something like that, the tail hook is there as an arrestor, obviously. So it's not impossible. It's actually more common than you probably think. But it's not a droppable tail hook. Basically, the tail hook, that's probably why this is so thin, because it simulates the full scale. So it's essentially, this just drops and hangs down like a loop-de-loop thing. So it's an emergency thing. So what we're gonna do here, starting off with the lights, is previously I have made some West Systems lens material from epoxy. So show you guys this stuff that I've got made is I just take some West Systems epoxy, put it in like a servo tray, and mix it up with some food coloring. And it's perfect for scenarios like this. So we've got the LED light sitting in there. When this thing's lit up, it's going to be visible from this direction only. Now, if we can replace this red thing with a piece of epoxy that's tinted red, that entire thing will glow when that LED is lit up. So that's going to be a way cooler looking setup. And then we don't really need that crappy lens installed on there as well too, because that's kind of cheesy looking. Looks like it was an afterthought. So we're just going to ditch that. And so what I'm going to do as a first step here is take my pull saw. We're going to cut this red thing off, and that's going to give us a bit of a template to use to make our replacement piece. Here is the blocks that I've made previously. So this is great. You essentially just use a bandsaw or a saw of some sort. You cut out the shape that you want, and then just use a sander and sand it down until you're happy with the shape. Now, it's going to end up looking sort of like that after you sand it. So you shoot it with a little bit of clear coat, and it ends up being shiny and crystal and awesome. All right, well, I pulled the pieces out of the molds here, and they turned out awesome. So the actual joint there, it's pretty visible. It kind of goes from epoxy to really light fiberglass. So you can definitely see the mold lines. That's probably a better side right there. But they worked out good. They're fairly stiff, fairly strong. Obviously, this entire section is going to be fiberglass together once we get it all cut out. And then this portion is going to be fiberglassed onto the other portion. So I think overall it's definitely stiff enough. I don't think we really would need to go any thicker than that. Initially when I pulled this out, I was thinking maybe I'll do another pull, but I think this is plenty. I mean, if I take this back piece here and try and bend it, it's quite stiff. So I think that's totally fine. So we managed to get some paint matches done today. So we got paint match number 1, which is our primary for the chute area. And then I also got this color matched as well too. This color is, we've got a couple chips on the underside where the gear door is. That's why I got these color matches done. And I think I'm thinking about doing something on the wings. So anyways, that's what else we got done today. All right, so we've cut off all of our excess material, and we just want to go through and sand these now. So we're just gonna sand this essentially, and just get it sanded down to our molding line. And of course, we're just going to take our time. And while we're doing this, we can put the two pieces together, check our fit, and make sure we're happy. So one of my big concerns with this is, are we actually going to be able to fit the chute inside this device? So I taped it up so it's stuck together, and we've got the chute jammed in the device. So it's quite important actually that it fits inside here, because our plunger sits right there. Now, essentially our chute is going to be, or our holder for the chute is going to be this big. Yeah, we really can't make it any smaller because it's pretty tight. So I think that'll work fine. Our plunger is probably going to be the same dimension as our square, I think is how I'm going to do it, is the plan. Yeah, so next thing we're going to do is we're going to tape off our outside surface, so all the way around the outside, and then we are going to fiberglass the joint here. So then we'll lay fiberglass cloth across the joint and get that epoxied in place. All right, so we've got our box glued together there. Everything turned out good. We put about 2 layers all the way around of fiberglass cloth, mixed up a small batch of West Systems, and now we will let that cure. All right, so it has been 24 hours since we glued this guy together. Let's pull our tape off and see what it looks like. Ow! Watch out for the fiberglass, it gets sharp. Ha! Super cool, wow. That actually looks really good. It looks like the epoxy kind of oozed out of the joints and filled that very nicely. So I'll have to do a little bit of sanding here and there, but that turned out really nice. I am happy with that. Super cool. Basically what we're doing here, our goal is we're going to cut along the color portion right there, and we're going to cut along the profile, so right in that area right there. So if we keep some of the red on there, that's fine, but that is the profile that we're cutting out. And I want to try and keep as much of that as possible so we can use that as our template. So just cut this off, vacuumed up my dust, and this is what it looks like. So we cut off the red as best as we could. We could just sand that off, but the benefit of doing it this way is now we can use this to kind of make our new piece. The new piece can be a little bit bigger, and the reason it can be a little bit bigger, if you take a look at what's here, we still have a little bit of a bump, so we can actually sand that down on both sides. And we don't have to, but ultimately we're looking for just a good fit. But I think it's going to be a better fit if we get that a little bit more flush with the fuselage. And that's what we're looking for. So the light is right there. When that light actually lights up now and we replace this all with the red epoxy and the green epoxy on the other side, this will glow instead of just seeing that little beam come out. All right, so we've got our piece cut out here. So my next steps when I do this is I mark my 2 dimensions. So what I mean by that, I'm always going to go a little bit big. So I'll kind of get this part centered. I'll take my thin Sharpie and kind of mark this guy out. So following the curve, just like that. And then what I'll do is I'll take the side profile and just kind of eyeball that guy. Not overly concerned. Again, just kind of getting it in the wheelhouse. So the point of doing this is to get this block of resin and food coloring now in the proper shape. So you can see kind of the dimensions we're following there. So essentially what I'm going to do is first I'm going to get this shaped to follow that, and then I'm going to get the height done to follow this. So we're going to end up with a big half circle shaft essentially, and then I'll slowly start to work on the angle. And I'm going to do all of that with my belt sander and just play around with this and get it shaped as best as possible. All right, so we just slowly work our way through this light. So I've got kind of the basic shape here first of all. And if we hold this up now, we know our length is good. You can see there it comes right to the end of the red. We've got plenty of width. You can see there we're wider than the original. So now we can work into final shaping, which is going to be the longest. So what I'm going to do first here is I'm going to take my file and I'm going to file this down flat. So then I can hold this up and I can mark the backside here with Sharpie. All right, so we flatten this out as much as we need to. I put a little recess there in our lens so it clears the LED light and sits flush. And then what I have done here is traced the back side right there. Also marked out the leading edge portion there. And then just made our nice shapes. We have a better idea now on how much material we need to take off, the shape, and everything. All right, so we got a couple options here when it comes to these light lenses. Kelly, thank you for this machine. This is so cool. Kelly donated us the vacuum forming machine, which is awesome. I think he did some repairs to make it work and everything. This is so cool to have in the shop. Thank you, Kelly. So we made the epoxy one here. This fits very well. So you can see there that we have a great fit for that area. Now what we're going to try and do is we're going to try and pull some pieces like this. I've already tried one, but I left the blue stuff on. So we're going to try another one without the blue stuff on and see what happens. So I'm going to put that in there. Okay, so it's going to get a little loud here pretty quick, so we're going to turn our vacuum on. So cool. Very nice. Now, of course, the molded piece is going to be a little bit bigger than our epoxy plug, but I think it's another option that we have. All right, so it worked out actually very well. I'm impressed with this. Now, the only downside to this particular light in this situation is our mounting. So gluing this guy on there, we'd have very little contact surface for the glue. So I think I'm going to pass on doing this type of lens on this scenario. And we're going to stick with our epoxy situation here. Now what I'm going to do with the epoxy now that we've got our shape dialed in, I'm going to take my Dremel and I'm going to hollow this out a little bit so we've got less material floating around the center. All right, so now that we've got these guys quite well fit, next thing we're going to do is glue them into place. Now, previously on builds, I have clear coated these and then put them in place, but I am going to do the opposite this time. And yeah, I think it's going to work just fine. It's going to mean we have to mask off some stuff, but I don't have a problem with that. So we're going to use, I think, some shoe goop and glue this in place because that's going to give us probably our best hold rather than CA, and we don't have to worry about it dripping anywhere. So I'm going to get those guys glued in place. Just going to put a healthy amount of shoe goop on there, tape it down, and let it cure. All right, so we've got our lights taped in place, and I think those are going to work out beautifully. I just decided to use shoe goop on the tail hook. This actually works out really well. I've done this before with scale bits and stuff, and we've got a great contact surface all the way down. And if for some reason this ever was wanting to come off, it's easy to take off. So that, I think, is going to wrap up the video. All right, guys, and that wraps up build video number 3 on the BVM F-16 Venom Scheme 1/5 aircraft. Happy with this episode. It turned out well. We accomplished a bunch. Next episode, we're going to start diving into more of the chute mechanism, getting that wrapped up and finished. And once that's wrapped up, we can continue to work our way forward into the front of the aircraft. We've got lots to do still, lots of modifications to make on this beautiful aircraft. So don't forget to subscribe. If you're not a subscriber already, roughly 50% of my viewers are not subscribers. So check down below. If you're not a subscriber, hit that subscribe button. Don't forget to give the video a thumbs up. And also don't forget to check out the Lighter Side of RC After Dark, where we do live streams here from the shop, usually every 2 weeks-ish for about 2 hours-ish. And you get to see the behind the scenes stuff. For example, the one that's happening tomorrow will be the stuff that you won't see in a video for about 2 weeks. So it's kind of a cool way to see stuff behind the scenes and also to interact with us as well too. You can ask questions during the live stream and all that. So thanks guys for watching, and we'll see you in the next video.